All right, let's get started. Okay, so I'm from Hootsuite. My name is Luke Kaiso, and I'm on the platform team at Hootsuite. And this is an example of when a platform team wants to take a team photo. They decide to lift things up because they're a platform, and inevitably the smallest person on the team is the one that gets lifted up. I'm also the co-organizer of the Vancouver PHP meetup up in Vancouver, and you can follow me on Twitter at @LKaiso. So, what I'm going to talk about today is where Hootsuite, my company, was 2 years ago. What made us decide to go to microservices, what the reasons for doing it were, and how we got to that architecture, and where we are today. So, quick intro on Hootsuite. So we're a social media management company. We're based in Vancouver. We basically let companies manage social media from one place, and they can just manage multiple different social networks. So for instance, when you log in, you have a list of all your streams, and so you can have messages from all your different Twitter accounts, your Facebook accounts, and LinkedIn accounts. So, free users will use it if they have a couple Twitter accounts. Small businesses will use it. They can schedule tweets and social media messages. And then really big enterprises will use it because they have whole customer service teams that are spending all day on Twitter, and they have different social network accounts. So it's all about like power management of social media. We also let you send messages across multiple different social networks. And we're the leading social media management company. This is our architecture. So we run fully in AWS. We run about 100 different 100 PHP nodes using Nginx and FPM. We have kind of your basic memcached, MySQL layer, and we have about 150 services running on other services. This is kind of our microservices layer here. And then we have another 300 services. So that's an idea of our scale. We have 10 million more now users. We hit peaks of 9,000 requests per second. And if you were at the WordPress scaling talk, it was about 10 million requests in an hour. This is 38 million requests in an hour, but every single request is unique because it's people doing stuff on the website. And we send out 4 million messages a day on various social networks, so pretty high scale. But let's go back 2 years ago. So Hootsuite started in 2008, and it was a typical startup story. Massive growth, build, PHP because it's fast, great libraries out there. And we kind of beat out all these other companies. So back in 2008, social media, big companies were like, okay, we can actually make some money off of this, let's figure it out. And so everyone was building these social media management platforms. And we were kind of in there. And so it was all about building features as fast as possible, and I'm sure you guys are all aware that when you do that, you build up a lot of technical debt and a lot of issues. So we just had this kind of hockey stick growth curve. We had 75 developers. We had this really, really big PHP app. And we kind of won, like we were the #1 social media management company. We had a lot of customers. But what we wanted to do was we were looking at the future, and we have 150 people. We're at 75 developers. We're going to go to 150 developers in the next 2 years. We're going to have way more users. Everything's going up. And this Monolith, this really big PHP app we're working on, is not scaling. There's a ton of technical debt. When you build features really fast, when you add people to your company really fast, when you have this hockey stick growth, things get really, really messy. And that's just the nature of it. So there's a lot of technical debt, and that was starting to lead to a lot of fires. So obviously you don't have great testing because that slows you down when you're a startup. So we had some good testing, but then people would change something in this weird code pathway down here, and then you release it onto production, and the tests never ran that code path, but suddenly no one can send messages, and that's kind of important for social media. And we just had a lot of these things where people were making changes, and the test suite wasn't good enough to cover it, and so everything started to slow down, and you have to be really careful. And this is a big problem for us, and that was only with 75 developers. Think about having 150 developers. We had a really, really good deploy pipeline, so we could deploy continuous delivery. We could deploy to production anywhere between 5 and 10 times a day, every single day. So this is great. It really helped us build lots of features really, really fast, get it out to your users. But there's just issues with it. So it would work great one day of the week. Someone would break something in staging, and then no one could release. So you have all your 75 developers working, and no one could release production. And then they roll out to production, and it would break in production. And then whoever had to figure out what was going on, it's never anyone's fault. It's someone else's fault. You got to figure that out. Roll back, and so everyone's paused. So even if you're one day a week out of 5, you're not deploying to production. That's 20% of your time, right? That you could be putting features out. And then that's only with 75 people. With 150 people, it's going to get a lot worse. So we needed a plan. Now, we could have doubled down on the monolith and been like, okay, what we're going to do is we're going to like make this awesome deploy pipeline. It's going to be really, really good. But the thing is, the nature of the beast is that that's not going to work, or at least it wasn't going to work for us. So we looked at microservices. So what exactly are microservices? Now, no, it's not a service for ants. So microservices are small applications. They're independently deployable, which is really, really key. So they can get pushed up independent of everything else. They're small, so one team can work on it, and a team can anywhere. At Hootsuite, they're between 4 to 8 people on a team working on a small service. They can bang them out in anywhere between 2 to 4 months. And they communicate only via APIs and everything else. So that's like the really key thing there. They're small services. They do one thing, one team owns them, it's a small team, and they communicate via APIs. So what we wanted to do was take this monolith here, and I kind of use these icons to represent different things we can do. So here's reading those messages. There's sending messages out. Here's team management, managing multiple teams because we don't let you. So for instance, if you have tons of people in your company, you don't want to give them all your twitter.com credentials, so you just add them to a team in Hootsuite, and then if you fire them, then they just delete the team. They don't tweet bad things about your company. So this is kind of the functionality we use. And then this is a representation of all the business objects, so essentially database tables. So your members, teams and organizations, and then credentials. There's obviously a lot more of this, but this is kind of a good representation. But what we wanted to do is we wanted to make the PHP app this thin layer at the top, which requests would go through. Then we would have this layer of functional services. So these would be doing things. They wouldn't store any data, but they'd be the ones that sending messages out. So you'd send an API call to the service, and it would send your message out. And then we wanted what here called the data services. This is basically splitting out your tables out into services, but they're small services. One team owns them. And then, for instance, the service that would read messages, you'd say, hey, give me my messages. It would talk to the credential service and ask for, okay, what are the person's credentials? Okay, I'm going to use those to send them right across to Facebook, and then send it back to the monolith user. So we wanted to split out our app into these services. Now, why? We're not the only ones doing it. This is a really big thing. Amazon, Netflix, Guild, they're all doing it. It's all about speed. Not of performance, necessarily, although it can definitely increase your performance, but speed of building things out, speed of getting stuff out to your customers faster, and doing it faster than your competition. A monolith slows you down at a point, and it's at that point where you need to move to microservices so you can release faster, continue to release faster, use your developers and your teams to work in parallel rather than concurrently, and get things out to your customers faster. So one example, deploy pipelines, I already mentioned that. You know, things are great, you're deploying, everything's going to production, and then something breaks in staging, and now everyone's stuck. Everyone's waiting for that person fixing the staging. Even worse when it gets to production, you have 75 people waiting for that one person fixing production. With microservices, each app has its own deploy pipeline. And so this team right here, 8 people working on this service, they break their staging environment, nobody cares. They can keep working, they can keep doing what they're doing. If they break production, people kind of care. But it's their job to fix it, and it's obvious what broke because it's their service. So you get a lot of speed here. You're not slowed down by people. Technical debt is reduced because you're working on small services. And when you're working on a small service, you can keep everything in your working memory. You can kind of understand the whole thing. That's a small team working on it. And so you can build things a lot faster because all you need to worry about is your one service. You're not worried about what you code is written has touched, this massive monolith you're working in. All you can do is just work on one service. It's going to have APIs, and it's going to work great. It also reduces technical debt because say we kept this really big monolith, 75 people, and then we're going to have 150 people working on it, right? Inevitably, what happens is you have these boundaries, these really nice objects, and things start to get hacked in there. Like, oh, I kind of want to access this field. I kind of want to do this. And so you get this really, really big ball of mud because eventually just entropy is going to happen and people are going to start messing around with your boundaries. If you have a service with an API, you can't really mess around with it because it's somebody else's service. You can't just be like, hey, can you add an API endpoint there for this hack? And they're like, no, you can't. So it really, really helps you with the scaling of your team up. And so when you have less technical debt, you can build things faster, you can release features faster. So again, so let's speed. Innovation. Who's tried to use a new language in their company in the monolith? No one, because it doesn't make any sense. Like, wait, we're running a PHP app, and now you want to run Node.js for this one thing that kind of makes sense side by side? This is not going to happen, right? What about a new database technology? What about a new library? A new version of a library? Like, let's start small, right? That's really hard to do. you have all this other code using it. You know, I don't even know how you do that in Composer, like using 2 versions of Guzzo at the same time is probably not that easy. My point is that when you have a really big monolith and everyone's talking and there's so many people involved, you just can't innovate really fast. If you have a small team, 4 people, and they're building this really cool feature, and they want to use a different language for it, they want to use a different database for it, just do it. They can just do it. As long as their API works, you don't really care what they built it in. And so, it's another example of just being able to innovate faster, being able to use new technologies, try out new things on a small service with a small team. You don't have to get buy-in from everybody. You can innovate faster, you can build things faster for your customer. So, kind of like the example that I had with the monolith, where you make changes in one place and would break everything else. Reliability is a really good reason to move to microservices. So, I'll give you an example. We have the service that sends messages. And for some companies, they need to store what message they send. For instance, banks or government, they need to have a record of everything they've done. So we have this other small service that's called archiving. And we use RabbitMQ to store the messages that they've sent for these banks, right? So it's like a really, really small subset. So in the monolith, what happened was that service went down. And the RabbitMQ library we were using didn't have a timeout. So it would try to talk to it, it would wait 60 seconds, which is the request timeout that we set for FPM, and then it would kill it. So it didn't really affect anybody, because except for the banks, their message didn't get saved, right? But what happened was we had such a high volume that eventually each PHP FPM worker was just waiting 60 seconds. And there was enough requests from all those banks sending messages that every single PHP FPM worker across the entire website was just stuck waiting for 60 seconds. And the whole website went down. So every single person that used Hootsuite, all 10 million people, couldn't use it because the banks had an issue with saving messages. So it's just a good example of what happens when you have, I mean, yeah, you would say, well, why don't you put a timeout on the RabbitMQ call? Yes, we did that. But the point is that you're going to have those dependencies and things are going to break. With microservices, you can isolate failure. So the service that was doing the archiving, if that went down, you know, that sucks. The banks can't send messages because that would be against their terms, but everyone else can, you know, use Hootsuite fine. They don't even know it was down. Also, when it breaks, it's kind of obvious what happens because you have monitoring on the service. So the one team can figure out what happened there, and they can fix it really fast. So your time to detection is a lot faster. When this RabbitMQ thing happened, we were all like, I don't know, like we were running around, our heads cut off, looking at graphs. We eventually used PHP FPM slow log to see that it was like being like paused in this one call, but that took maybe like 20 minutes. That's a huge, 20 minutes is huge for a big company. So with microservices, you isolate your dependencies, and you can kind of really, really increase your reliability. Scaling. So say you make this really awesome feature that's used really, really heavily between 9 a.m. and 10 a.m. If you've done that in the monolith, and people start using it, and it's starting to take down your site because so many people are using it, your only option is to scale out the monolith, add more nodes. This has a ton of other knock-on effects because you have such a big architecture. So, for instance, MySQL connections. Now you've doubled your number of MySQL connections based on MySQL server for this one feature. Scaling out a monolith, especially one that's really complicated, has a lot of issues, and it's just harder to do. It's slower moving. If you wrote a service and a microservice that had that feature, you could scale that out separately. One team could do it. They could bring it up at 9 a.m., add a couple nodes, bring it back down. It won't affect anything else. So if this is a good feature for your customers, you know, you've gone from breaking the site and having this all things really bad to suddenly you can scale this up really simply. And so it's all about being able to build things a lot faster for users and having a lot more flexibility. So this is kind of like, that's the pitch you can give to your boss. It's about speed and bringing things to your customers. And it's also the pitch you can use, you know, for yourselves because it's awesome to work on these small services. It's a lot of fun. You don't have to worry about integrating things with this model. You don't have to worry about this crazy tests and all this old technology. You get to build things that are really cool. You get to try out new things. And as a dev, it's just really awesome to be able to work on a small team and not have to get everything through this unique model. So to sum up, you reduce your deploy bottlenecks. It's easier to scale, and it's a lot simpler. So that's kind of the reasons why you should go for Monolith. And now I want to talk about how we tried to do it. It sounded like a good idea at the time. It was. So what we want to do is go from this big monolith over to these kind of services. The first thing we did was we built a prototype, as all good engineers do. We actually started to move towards using a new language, using Scala for our microservices. And so part of that prototype phase was, well, can we write Scala? So we wrote a service that would do PDF conversion. Super simple, you send it HTML. It would give you back a PDF. You can do that in PHP in about 2 seconds. You use like PDF to HTML, and once you're installing, you're done, right? But this is kind of the idea. You want to try these things out on new services. So we were also using a new networking layer, Zero-Q, which is like TCP. Basically, we had a lot of different technology things we wanted to try out, and so we built a prototype of it. So this is the architecture. You have your brokers, your load balancers, and then you have these are nodes. And so it's not really important what we did here. The point is that we did a prototype to kind of prove out that we could build these services, that we could talk to them by APIs. We figure out what libraries we're using for the monolith to talk to these services. Okay, so that worked fine, but that's just a small service. It doesn't really get us where we want to go, right? So then we started looking at, okay, what's the plan for splitting up a monolith and for building these services? Now you kind of have two options if you're like, let's do services. First option is to build all your new features out as services, and that's great. The problem with that is all your new features will be using everything from the old app, because, I mean, probably, most likely. So if you're building a new service that's sending messages to Instagram, well, you need to get the authentication credentials from the monolith. You need to get who the message is from the monolith. So everything's starting to tie back, right? And so now you're doing more development on the monolith to make it so your service works. And so building new features out as separate services is great, and you shouldn't build them on the monolith. But also, that's not really enough to get you that speed increase that you need, and it's still going to slow you down. So the second thing you can do is start actually refactoring, pulling things out of the monolith. So what we did was we looked at all the different business objects we had. So this is an example of 3 of them. So organizations, teams, and then teams are made up of members. And we mapped out the dependencies. So these are literally just database tables or the nouns in your system, the objects in your system. We mapped out all these different dependencies. And then we saw that the members were kind of like the base dependency there. So if I was going to build a team management service, I would need to talk to members. If I was going to build an organization service, I would need to talk about teams. And so that was kind of the leaf dependency. So we picked that as the first thing we were going to build out as a data service. So a data service essentially just wraps a CRUD interface, create, read, update, delete around a database table. But this seems really like small, but it really, really is useful when you're building all these new services out, and now you have this one service that does members, and you can iterate on that a lot faster. So this was the plan. You're just going to split out members out into its own service. Kind of a risky plan because it's so important. So every single time you hit the website, we get information about you, so we know what to show you, right? So every single request hits the service, so it needs to be reliable, it needs to be performant, and also in the PHP code, it's used everywhere. So this was a good test because it was so intertwined. It's such an important service. But it was also very risky because if it all went awry, it was going to be bad. So we did it in zero downtime migration. Zero downtime. I'll talk about that a little bit later. But basically the idea is the first thing we did was we created the service. So we wrote the service up. It's literally a simple CRUD app. Then we started replicating. So this is the database from the monolith. And so we started replicating the database over here so it had the same data in it, the same memory data. And then when we would do writes to the database, so you update your username or whatever, we would write to both databases so they stay in sync. And then we'd read from both databases, but we'd only use the data from this database, and what we would do is we'd diff to see if there's any difference in the data between the two databases because of like different APIs or whatever, right? So we basically want to make sure the data is the same. So we ran that for a while, then we fixed the service so that everything's returning the same data, and then we cut this off. So that's all happening in our production. So at Hootsuite, we really, really heavily rely on dark launching. Dark launching is basically just an if statement, and this flag can be turned on and off in production. So here we would do, if the dark launch is enabled, we'll get the member object from the new service. Otherwise, we'll get it from the database, from the monolith. And we have a really awesome system that lets us control all of this in different environments across production. And so here's that dark launch code. And we just log into the management panel, and we can scale it up for a certain percentage of the users. We turn it completely off. We could have it turned on for just our organization, just my member. This is really great when you're working in a monolith, especially because you can kind of release things out, merge them in a master, and get it out to production, and then just test it for yourself and make sure it works in that environment. And it's really great for us because we can turn it on and off the dark launch if something went really badly. That worked great. The problem with dark launch codes is that you have to kind of get your keyboard to turn things off when it breaks. So once you got the service running and it was working, we employed what's called a circuit breaker. So just like in your house, when something takes too much too much power, it cuts the circuit so it doesn't break, right? So the idea here is we would log all the different failures to our service, for instance, timeouts or weird exceptions. And if we got a certain number in a minute, we would cut it and we could go back, fall back to the old database. Part of the downtime migration, if you're leaving this overnight, you can't really be watching it all night, and you don't want your ops guys to wake up and flip a switch. This was really awesome until we actually started using it, and this happened. So the problem here was that this little log call here, because you want to know if it's breaking, right? Well, inside that log call, we also want to know for which memory it is breaking. So the logic path here is, oh crap, the service is not working. Let's log it. Okay, we're going to log it. Let's get the memory ID. Okay, let's call the service. Oh crap, the service is not working. Okay, let's log it. So this is an infinite loop. So this took down the website. So there was zero-ish downtime migration. But we did fix that. And this circuit breaker is a great pattern if you implement it without fucking up. And it was really good, and it's helped us kind of be safe and run overnight and not be really too worried about it. Now, one thing you're going to run into when you start to build out all these services is versioning. So versioning sucks, because say you built this member service, it's super awesome, and you have like the /members endpoint, and then you want to rename it to /users, because, I don't know, you're mic check or something. And so if there's 12 different services that are using your API, you now need to contact every single person who's owning all those services and be like, hey, can you schedule sometime in your sprint, now, to update that endpoint, and also we added a new parameter? Okay, that's not going to scale very well because people have priorities, they don't really care if you rename your endpoint, it's working fine for them. So a good practice that a bunch of people use is to write SDKs that wrap your API. So all you give people is a composer package, and it has a couple of different endpoints in it, but they just call like the get, create, update, delete. They don't really know what's happening underneath here. It could be sending an HTTP request, it probably is. And then you also have the name of your endpoint inside that service. So when you want them to update, you just tell your 12 different services, hey, can you just run a composer update? Which they're doing anyway, hopefully. And so they get the new version. And so this is a way to kind of version your API without actually having explicit versions, because that runs into a lot of problems. And it's something that's small, you wouldn't really think about when you first start, but if you're looking at, okay, we're working around like 100 different services, then it's a really big problem if you have all these versioning issues. So SDKs are a really important part of that. So there's a lot involved in this service extraction, and that's kind of why we tried it out. We used Kibana for logging. It's the Elasticsearch log stack, Kibana stack, BLK stack. Basically, we send logs out, and they get all aggregated into this big Elasticsearch cluster that lets you search. So up here, you can type things like, show me all the different calls to the member service from this one web node, because I think it's being slow, or I think it's got issues. And so you kind of drill down. If suddenly you get a ton of errors in your logs, you can look at it and you can click on like this sort button over here, and it'll tell you, well, 90% of these errors are from this one node. So then you can kind of isolate errors. So really, really important to be able to monitor everything you've done in production, because monitoring a monolith is a little bit easier than monitoring 50 different services, right? So you want to make sure you have this logging enabled and being able to do all this real-time monitoring, because things break in production. We also use Graphite. Graphite's basically we can send it timing data, we can send it counts for how many calls have been made, and we track this across all the different services. Graphite's really awesome because you can send it a ridiculous amount of data and it'll just degrade gracefully. So really, really useful. Unlike kind of the log stash, where Elasticsearch kind of will die if you send it 3 million logs in a minute or something. Graphite can degrade gracefully. And this is really useful. We use it for things like checking out the timing for the service calls. Because previously it was a database call, which is really fast, but now you're talking to this new service, it could be a lot slower, right? And you don't want that on every request. So we use this in production to find out everything about our service. So to sum up, it was a lot of work. And we started with dividing the business objects up. We mapped out the dependencies. We picked the service that we were going to extract. And then we used dark launching and circuit breaking to make sure, as we rolled it out, with zero downtime, it didn't break everything. Zero downtime. And also, we used SDKs to avoid versioning, and we used monitoring. So that was the very first service, and it was successful. And it proved out that we could do this, that we could pull these huge things out of the monolith. And that kind of catapulted us. It gave us the ability to keep going. Now, I said it took a month to build the service out. Any guesses on how long it took to roll it out until it was running 100% production, and we weren't ready to build it? So who thinks it was another month? Who thinks it was 4 months? Yeah? That's
6.5.
6, no.
1 year.
It was 4 months to roll it out in production, which seems ridiculous, right? And it still seems ridiculous, but it's true. And then we've done more services, and that's like the extracting from the monolith part is the hardest part. So we had to do a bunch of stuff. We tried out new technologies, SDKs. There was lots of issues rolling it out. So one thing we had to run into was we would, at 9 a.m., which is when we get our peak traffic, we'd get all these timeouts to the service. So we're like, well, what's up with that? And what we tracked down to was essentially every single service call is opening up a TCP connection, and we have 40 FPM workers on each box, and we have 100 boxes. And that would just overload our network because you're having 9,000 requests per second. Each one's opening up a TCP connection, and so it was just saturating the network. So what we had to do was build a connection pool. So each node would only connect to localhost, and there would be kind of a daemon running, and then that would pool all the connections out to the service. So this is an example of things that just go wrong and you don't really think about it. That's kind of why things take so long. But we got better at it, and the service extractions got faster, but still, hard part was that. So this is Conway's law, which is basically that the software you build is going to look like the structure of your company. And this is some examples. Sorry for the horrible dig there. This is my comp. This is basically the structure of some organizations. So at Hootsuite, we use strike forces, which is basically teams of people come together, they build a service, it's awesome, and then they disband. This is great as a developer because you work on tons of really cool technology. It's great for the company as a startup because people are involved in everything and you're building things really, really fast. There's some downsides, which is when that feature breaks, whose job is it to fix it? Well, all those developers are spread across different teams, right? So as we mature as a company, we're like, okay, well, we need to kind of have some stability inside the team structure. So you have two options there. You can divide up into specialties, so you can have your UI guys, your PHP guys, your database guys, your JavaScript guys. The problem with that is that if that's your structure, then that's what your services are going to look like. So then you're going to have like the front end service, which I don't even know what that means, but basically just front end guys.
Hi. So unfortunately the audio recording cut out there, but I had a couple more slides, so I just doing a screen recording to finish up the talk. So where we left off was talking about organization structure. So one of the problems I was outlining was that if you have your organization organized around specialties, so you have a front end group and a middleware group and a back end group, then what you build, your software is going to look like that. So you're going to have a big front end tier, you're going to have a big middleware tier, essentially Monolith, you're going to have a back end tier and a database tier, and essentially looks like that. And the problem with this is it doesn't really match very well with microservices, because with the microservices, you kind of need to be able to own the full stack. So even if the microservice is itself a back-end service, you're going to need people that know databases. And then if it integrates with something on the front end, then you're going to need to know people that know front end. And so what happened at Hootsuite was kind of a lucky accident, but we moved towards productization, which is essentially we took our product that lets you do lots of different things, and we split up teams of people around the areas of that product with the goal that we could, build out each area better and sell it and keep it stable so people would own that part of the product. One of the added benefits of that was that each team ended up getting a lot of people that knew lots of different parts of the stack because they had to be able to build those products. So what we moved to was something like this. So the different color developers on the left there represent different types of roles for each developer. And so we ended up having teams where we had lots of different developers that knew lots of different things. And this leads itself really well to microservices because you can build out a full service and understand how it interacts across the stack and you can work together as a team really nice and fast, and so you're not waiting on other teams. And so this really lends itself well to microservices and lets you build these services a lot faster. So kind of a team organization is important here. If you're really well siloed and there's a lot of communication, you're going to be a lot slowed down with your microservices, and maybe it doesn't make sense at your organization. All right, so what we affectionately call the service-oriented monolith was something we came up with when we were trying to build out these new services and new features. And what we found was that there was just so many things from the monolith that we needed to access. And we had all these new features we needed to build, and we didn't have time to stop the whole company and rebuild Monolith out as separate services. So what we did was kind of this stopgap measure. So we essentially just wrote a bunch of APIs, but we wrote them on the monolith itself. Now these APIs didn't exist before because, for instance, if you wanted to get information about an organization, previously you would just make a PHP call within the monolith. But now we kind of wanted to simulate that we had written 18 different data services, and these are an example of some of the data services, without actually writing them because, as I was mentioned before, with the member services it took 4 months, so if we wanted to do 18 of them it would take a long time, and the business just doesn't really make sense for the business. So we managed to build all these out in 2 months, which was really awesome. So essentially we just wrote a simple REST API for all our business objects that would just call the internal database. Super simple. But then when we build a new service that needed to know about social profiles, it didn't have to build out the social profile service first. They could just build their service and then call the API on the monolith. So great for that. It enables new services to be built. The downside is that you're totally faking it out. And so the same problem you have with monolith, as in like if you need to make changes to the API, then you need to make your changes in the monolith, and it's hard to scale if people start using the API really fast. It's fragile. You still have all these problems. But as an enabler for new services to be built that probably wouldn't have been able to be built as services, it's quite useful. And also as just a reality of an organization, you can't just move directly to microservices and stop everything. So this service-oriented monolith, we called it, as a joke, is basically something we use to allow us to build out new services faster. So where we got to was, at the beginning we decided to move to microservices. We built out a small prototype to make sure we could do it, tried out some new technologies. Then we looked at the monolith and figured out how we were going to split it up. We split it up into business objects, bounded context, domain-driven design. We built a leaf node out, the member service. We also luckily reorganized into product teams, and this lent us really well to microservices. And finally, we used the service-oriented monolith kind of pattern, basically APIs written on the monolith, to enable us to build out new services that we probably wouldn't have been able to do otherwise. So what are the lessons we learned? The number one lesson is that splitting things out of the monolith is really hard. Kind of like the example with member service, where it took 1 month to build it and 3 months to bring it out from the monolith. Extracting your business object from a technical debt-laden monolith, it takes a lot of work, and it's difficult, and things can go wrong, and you got to be really careful. And it's a lot harder than you think it is, and it's hard to estimate how long it's going to take. So that's something we really learned, is that bringing these things out of the monolith is really hard. The second thing we learned is prioritizing the work, such as splitting things out of the monolith, is hard, because you're at a business, they need to build new features for the customers. And so to be able to prioritize, hey, can we spend 4 months, one team, just pulling something out that already totally works fine, is hard to prioritize that. And I mean, that's just the reality of any business. Now, this is necessary because in the end, it's going to pay dividends. It's going to help the business scale. But it's hard to prioritize that long-term gain for short-term needs. And that's just the reality of it. Number 3, DevOps is hard. So when you have a monolith, it's pretty simple to deal with deploying it and monitoring it. But when you start to talking about, going to build out, 5 services and then 30 services and then 100 different services, suddenly you need to have radically different tooling, radically different DevOps technology. You need to build in a lot of efficiencies to make this possible for your developers. And so what we're running into now is that, DevOps managing all these things, all this tooling is really hard. So in the future, we're going to keep building out more services and building out new features of services, and also to keep trying to extract things from the monolith. We're really investing heavily in deployment and DevOps tooling because we see this as a potential barrier for growth and speed for us in the future. So we're looking at Docker and potentially Mesos as technologies we want to use to kind of improve the way we deploy these services out. We're also going to be honestly continuing to write code and features on top of the monolith. The reality is that there's lots of features still in the monolith that need to be iterated on and improved and fixed, and so there's this high proportion of the team still working and building things in the monolith, and so we're still investing in tooling for the monolith, and that's just the reality of it. It's difficult to be able to prioritize moving the whole team to microservices all at once. It doesn't really make sense to the business. So why would microservices be a really bad idea? I kind of just pitched why they're awesome for us, but it definitely doesn't make sense in all cases. The number one problem is increased complexity, and that's a huge problem for software engineering. You need to keep things simple, and if it doesn't make sense to add all this complexity, which you are totally adding when you start to build out all these different services and have them communicate via the network, it doesn't make sense to do it. So you really got to weigh the increased complexity you're going to be adding to your services with these. So now you're dealing with distributed systems, eventual consistency. It's a lot harder to refactor because you have APIs and you need to have all these people that use the APIs and you have teams that run the different services. And so you're just adding a lot of complexity to your system. A lot more things can go wrong even though you do isolate failures. And you just really have to weigh the increased complexity and whether or not it makes sense for what you're trying to accomplish. I kind of already talked about this, but you absolutely need excellent DevOps. You need to be able to provision things really fast. You need to be able to deploy. You need a great staging environment. You need to be able to figure out how you're going to do testing for all these things. You need to be able to do good logging. We spend a lot of investment on our our Elasticsearch log stack, Kibana stack, to make sure it could handle the high number of logs all these services are sending. You need a great DevOps team. You need everyone to know how to run services, and so you need excellent DevOps for this to work. Third thing, reorg is pretty important. We kind of did one anyway, and so it was just really great for us. But if you're working on a team where you have an ops team that's siloed and you send tickets and they take months to get resolved, and you have your front end developers and it's all ticket based and you're all siloed, it's going to be really hard to use microservices and increase the speed with which you build things because you're still going to be waiting around and you're not going to be able to iterate really fast and you're not going to be able to work as a small team. So you need to be able to own your own stack. You need to have different developers at different skill levels and skill types in a single team so they can work on their service and own it. And that's really going to get you the meat of what you need from microservices. So that's the end of my talk. Thanks for listening, and thanks for listening to the screencast at the end. You can follow me on Twitter at @lkaiso, and if you have any questions, just tweet at me. Thank you.